Okay, so we have 10.3, which is monthly payments and interest, and you have, with this, you're going to have your three type of loans. Your first one being conventional loan, which belongs to a commercial bank or mortgage company, which it usually requires 5 to 20% down payment. And then you'll have your FHA loan, which means your Federal Housing Administration, and it often allows a 3 to 5% down payment. Then you have your VA administration, or VA loan, which is a Veterans Administration. It is available to only United States veterans. So now we begin our first example. Example 1 says, both Mr. Kane and Mr. Farmer must borrow to purchase their new $90,000 homes. Mr. Kane wants to take out a conventional loan and required a 10% down payment. Mr. Farmer wants a FHA loan that requires a 4% down payment for each buyer. Find A, the down payment, B, the balance to borrow, and C, the monthly payment in Mr. Kane's loan, the monthly payment. If Mr. Kane's loan has an interest of 8.5% for 36 years, or 8.5% by 12 for 36 years, and Mr. Farmer's loan has 7.625% for 12 years, or 12 interest rate for 30 years. So here we go. We're gonna start this. So Mr. Kane, he has his $90,000 home. Okay, let's move this up. So he has his $90,000 home. So you need to find 10% of that, and 10% as a decimal is 0.10. So then that's gonna equal 9,000. So then you subtract 90,000 minus 9,000, and that equals 81,000. So you gotta remember those numbers because you're gonna need them for this next part. So in 6.4, it gives us a formula. You'll reference that, and so in there it sets up the formula for us. So we'll just fill in the blanks. So you have 0.085 over 12 over 1 minus 1 plus 0.085 over 12 to the negative 360. So then that's going to come out to equal $622.82 per month. And so that's Mr. Kane's. And so now we got to find Mr. Farmer. Mr. Farmer, we're going to do the same thing but with his numbers filled in. So he still has a $90,000 house, but he's doing it for 4%. He has a 4% down payment. So 4% of 90,000 is $3,600. And so 90,000 minus 3,600 equals $86,400. So now we're going to fill in the numbers again. Reference 6.4 yet again. 86,400 goes here. And so then 0.07625. We got that number because that is his interest rate for 36. So 36 years, and so then we're gonna do this. And so then 1 minus 1 plus 0.07625 over 12 to the negative 360. And so that's going to come out to be $611.5 which is actually cheaper than what Mr. Kane was paying, even though he had a higher down payment. Okay.
Okay, so now for this, so this is still part of example 1. So it says here the amount that goes towards interest is very large when the loan begins. For example, Mr. Kane's $81,000 loan at 8.5% times 12 occurs at 573.75 interest the first month. So here, so how we're going to figure that out is we're going to put the 81,000 times the interest, which in the decimal that will be 0.085, and then times the time. So we're going to put that into a fraction. 1/12. And once you do that on your calculator, then that should equal 573.75. And then now since we're trying to find out Mr. Kane, so you're going to go back to the other problem and get his interest per month, and which was for him it was only 622.82, and then we're going to subtract that by the interest. So 573.75, and we get $49.07, and this money is going to go back to paying the principal. The principal amount. Okay, so now for example 2. So you're probably going to need to use example 1 for this one. So it says, in example 1, how much of Mr. Farmer's first monthly payment goes A, to interest, B, to pay on the principal, and C, find the new balance due after the first payment. So we're going to view the first month's interest as a loan of $86,400 at 7.625% simple interest for 1 month. So we're going to use interest equals principal rate, and then the time. So we're gonna put down what they told us, which was the $86,400 times times the simple interest. So we're actually going to move our decimal over on that one. So it would be 0.07625 times the time, which is going to be for a year. So that's going to be 1/12. And that's going to equal, if you did it on your calculator, that should equal 549 interest per month. Okay, so then from here, we're going to subtract the monthly payment, which was in example 1. Yeah, the monthly payment, which was in example 1, which was $611.54 minus the interest in the first month, which was $549, and we're gonna get $62.54. And then from there, all we're gonna do now is just subtract the loan from what we got from subtracting the monthly payment and the interest. So that'd be $86,400 minus $62.52, and that would be $337.46 still owed. And that will be the end. That will be the answer.
Okay, so now for example 3, we have to find the actual amount Mr. Farmer will pay for his $90,000 house and how much interest he paid. So first, we're going to find the amount paid over the life of the loan that he would make. And so he would make 30 times 12, which equals 360 payments. So since it is each month, you would do 360 times 611.54, which comes out to be $220,154.40. Just put that in right there. So then we got to include the down payment from the example 1 to find the total paid. So the down payment was $3,600. So we will do 220. Oh, that's in the wrong one. Erase that. So it'll be $220,154.40 minus, or my bad, plus, don't minus, $3,600, which comes out to equal $223,754.40. So then for 3, we got to find the total payments. We got to have total payments minus amount borrowed, and that's the interest paid. So you'll do $220,154.40 minus $86,400, and that comes out to equal $133,754.40. Okay, and now on to example 4.
Okay, so in example 4, we have to find A, the monthly payments, and B, the amount applied to the principal the first month, and C, the interest Mr. Farmer, in example 2, would pay if he takes out a 15-year loan at the same interest rate as a 30-year loan. So first thing we have to do is we have to calculate the monthly payments. So we're gonna actually try and find the rate. So R equals 86,400. So the 86,400 was from example 2, because it said you needed to look in there. And then we're gonna bracket here and the interest here, so 0.07625 over 12, and over 1 minus parentheses 1 plus the interest again, so 0.07625 over 12, and then times negative 80, and we close that, and we would get 807.09.